cover the four concept: composition, odd and even function, symmetry, and the inverse functions. So in this in inverse, we will try to find how to find the inverse of any functions. These four concepts are the basic and the building blocks to understand any functions. In graphing, in derivative, these concepts comes in everywhere. So please give your full attention over these topics. So first we'll go to the composition. So before going to the composition, just you need to have a basic understanding that what is composition. Composition means combining two functions. Suppose if I have fx is equals to 2x and gx is equals to x plus 4, how do I write by combining these two functions? These are the adding these two, dividing, subtracting, whatever we do, that comes into the compositions. So I would like to teach this concept with some example. Always remember, if we combine these two, how do we write? Function of f in gx, or this could be function of g upon fx. Both of these are different. That means f of g or g of f. This is how we read it. Let's go example. Suppose if you have one function fx is equals to 2x minus 1 and gx is equals to x square, then you need to find function f of gx, or this can also be written as function f in gx. This is also how we write this function. Find f of gx and also find g of fx. Finding g of fx, and then you need to see if these two are equal or different. Okay, let us solve this. So first, if we want to solve f of gx, what you need to do? First, write the value of gx. Gx means x square, right? So write x square. What am I doing? I am just replacing the value of gx into x. Now the term came for function f. Function f means 2x minus 1. 2. In place of x, what you need to write? X square. 2x square minus 1, right? So this is our f of gx, 2x square minus 1. So this is the first part. Now let us solve the second part of this function. Second part is finding g of fx, or you can simply write, or which also means finding g of fx. Now what you need to write? First write the function fx, that is 2x minus 1, right? Now in place of x, replace this, that is 2x minus 1, and g just square it, and now we can do the square. This gives us a square minus b square, that is a square minus 2 times 2x minus plus 1 square. This gives us 4x square minus 4x plus 1. Now from here you see that function of f of gx is 2x square minus 1 and function of g of fx is 4x square minus 4x plus 1, which are not equal. So the f of gx and g of fx are not equal. So this was the concept of compositions. Hope you understood it. After we finish the functions, and we will do some more questions related, more MCQs related to this, and also we also try to solve some of the questions that came in the previous year APs. Okay. How about let's do one more example. Suppose if fx is equals to 4x square minus 1 and gx is equals to root x, how do you find f of gx? Okay, so finding f of gx means root x, right? So now put root x in, now in 4x square minus 1, put root x in place of this x. 4 times root x upon whole square minus 1. I am just substituting this x in there, so which gives me 4x minus 1, because this 4 and this root and these two cancel out. That means gives me 4x minus 1, right? And how do you write g of fx? Let us do this. Function f is 4x square minus 1, and if I just do root over this gives me root under 4x square minus 1. Here also you can see that for these two are not equal. Okay, this was the concept and composition. Now let us go to the next topic, that is on symmetry, right? But before finding symmetry, you need to understand what is even function, and what is odd function. What is even function and odd function? So once you know that, then only you can say that whether these functions are symmetry or not symmetry, right? Okay, for finding even functions there is only one criteria, that is if you put negative sign on x, and if that, by putting just negative signs, if that makes the whole function negative, then this is our odd function. Next is, if I put negative sign and that does not change the any value of function, just it gives e of x, then this is our even functions. Only this is the difference. You see the difference is here. It is, if by putting the negative x, if that function changes whole as a negative, then that is our odd functions. And if that does not change, that is our even function. Okay, now let us do some examples so that it will be more clear. Suppose if I have one function fx is equals to 1 by 2x cube. Okay, now if I just add negative sign, what will happen? It will happen 1 by 2 minus x cube. So for negative sign, the minus comes in front, right? Minus 1 by 2 x cube. That means this is minus fx, right? Because this and these are same. So minus fx. See, by just substituting the minus sign, these functions became negative. Then this is an odd functions. Now let us do one example of even functions. Now if I write gx is equals to 3x square minus 1, 3x square minus 1. Now if I substitute negative sign over here, what will happen? 3 times negative x square becomes positive, right? This means just squaring, that is 3x square minus 1. What happened? You can see that gx is equals to negative of gx is equals to positive of gx. By adding negative sign, the function did not change, and this is even functions, right? So this is how you find odd function and even functions. Now let us do the graphing of these functions. Later you will understand how to do graphing, but for right now we just see what happens in graphing. So if I let us okay, sorry, okay, fine. Let us remove this. Okay, now if I just write, if I am going to plot these two functions fx, first let me plot fx. What is the value of fx? Fx is equals to half x cube, right? So for x cube, the graph is something like this. The graph becomes, this is the graph of x cube. For right now, don't see how this graph came, just understand the nature of the graph. And for gx, the graph, what is the function of gx? The function of gx was 3x square minus 1, 3x square minus 1, and the graph is something like this. Okay, so this is the graph. This is a rough picture. Now what you see here is the graph of an odd functions is symmetry about the origin. I think upside this side, now you can see from here and here they are just two part. One is just this and another is just this, right? So these two graph are graph of an odd function is symmetric about the origin. Symmetry means, suppose if this is a curve, this side and this side become same, that is symmetry, right? Suppose this side and this side are same, that is symmetry. So for odd functions the graph becomes symmetric about origin, that is from index axis, right? Even functions is symmetric about y-axis. Upside and down are same, left and right are same. So this is symmetric about this line and this function is symmetric at this line, right? So this is how we define it. Now let's study some more concept. Suppose I have one functions, okay? So let us write f x is equals to 2x plus 1. So this is my ex and this is my 1. If I write here 1, 2 into 1 plus 1, 3, right? If I write 2, 2 to the 4, it becomes 5. If I write 3, 3 to the 6, this function gives 7. That means these all functions are 1 to 1, right? A single domain gives a single range, that is. So if a function f yields a single output for each input and also yields a single input for every output, then this is a 1 to 1 functions. Means if it is an 1 to 1 functions, suppose if I draw the horizontal line over here, these horizontal lines got these functions at 2 points, right? So this is not in 1 to 1 functions, because if I draw the horizontal line, these functions got this line got these functions at 2 point, got these graphs at 2 point. But in this case, how much I draw the horizontal line, these functions only got at 1 point. That means these functions on the left side, this function is 1 to 1 functions, but these functions is not 1 to 1 function. Now this is all about the odd even and the symmetry. I think this is just a very basic reminder of odd even and symmetry. Later in coming days we will solve in more detail. And now right now, before moving to inverse, I like to just make one point. If this is an fx, now we are just moving to the inverse of these functions. If you deduct fx, if I write f inverse x, then I am just writing these functions inverse. F just minus 1 means that is the inverse of that functions. For finding the inverse, the functions must be 1 to 1, okay? Is that clear? For right now, just understand this. This is a very skills. This may change in the after before, so in coming lecture. But right now, just understand this is in 1 to 1 functions. The inverse of fx is f inverse x. Now, how to find the inverse of functions? Suppose if I give you just fx is equals to x cube minus 1, how do you find the inverse of, how do you find f inverse x? Right? So this is, now we will solve how to find the inverse of the functions. Suppose fx is equals, suppose y is equal to fx. This is same because fx is equals to 2x plus 3, right? If I write 1 over, it gives me 2 into 1 plus 3. This is 5, so this is my y. So this means y is equals to fx. This is how we represent the function, right? Now fx is equals to x cube minus 1. Now how do we find y? Now just write these functions. Now in place of x, fx, write y. Y is equals to x cube minus 1. Is it clear? Clear, right? Now what we do is interchange x and y. Interchange x and y. Very simple. In place of y, x write. In place of x, write y. Y cube minus 1. I think this makes sense to you, right? And just separate y. Y cube is equals to x plus 1. Or you can write y is equals to root 3 x plus 1, right? And this is the f inverse x. As simple as that. So fx was x cube minus 1. Its inverse is root x cube of plus 1. Or this can also be written as x plus 1 by 1 over 3. This is how we solve it. Is it clear? Okay. Let's see. Now let's do some graphing. If I draw the graph of fx is equals to x cube minus 1, the graph becomes like this. Okay, and this is the graph of x cube minus 1, y is equals to, and this is the graph of y is equals to x. And now for inverse functions, the graph will be just symmetry to it. The graph will be something like this. I am just rotating these functions. You see how this is functions is coming. This is the inverse of x. So these functions and these functions are the mirror image of each other. Inverse functions are always the mirror image of each other with the line y is equal to x. Y is equal to x means any line just passing through origin. This is a straight line passing through x. This is a y is equal to x line. In this line, these two functions became the mirror image of each other, right? You see, this is the mirror of these functions. Now, just one very small concept, zeros. The zero of a function f. The zeros of function f. What is the zeros of function f? Zeros of a function f are the values of x for which fx is equal to 0. X values, what are the x values when fx is equals to 0 are the zeros of function f. Suppose if I solve, let us do an example. Fx is equals to x4 minus 2x square. Suppose, how do I solve it? The value of x for which this becomes 0. That means x4 minus 2x square is equals to 0. That means if I just x square, that means x square minus 2 is equals to 0. So I can say that x is equals to 0. From here I also can say that x square minus 2 is equals to 0. That means x is equals to plus 2 and x is equals to minus 2, right? This is what it is about. So today's we finished this all the concept that I told earlier. So I think it becomes a very good lecture.